Hi there. I'm Craig. I'm from South Africa, and I'm a security researcher. And what I want to talk to you guys about today is some of the research we've been doing into AWS for quite a while now. But I thought maybe before I do, I should maybe just introduce myself. So I didn't actually start off doing research. I started out as a consultant, and it was really exciting. I got to do a lot of very interesting work for a lot of very interesting clients. And I think for me, the sort of common theme of what made a project exciting was when I got to learn. So when I got offered an opportunity to do research full time, I leapt at it. I think that really sort of gelled well with me. Why AWS though? This really wasn't actually my decision. I just sort of inherited it. But I'm really happy that it happened because it turns out there's some really interesting problems there, which is actually what I want to chat to you guys about today. So I hope you agree with me. So yeah, AWS is really very broad. I think a lot of you might be quite familiar with it, maybe some less so. So I think for everyone's benefit, we're sort of going to start this talk off by just basically getting some of the necessary background information out of the way, and then we'll sort of really introduce the problem statement, or the problem that we're dealing with, and how we're trying to solve that. Good, so yeah, I hope you guys have had your coffee, because we're going to jump in right into AWS. At a high level, it really just consists of two things, EC2 and everything else. So EC2 is Elastic Cloud Compute, and it's very similar to what we have in traditional on-premises environments, where you're responsible for managing everything from your applications all the way down to the bare metal that they're running on. EC2, you still manage quite a lot, but AWS takes on some of the responsibility. So they'll manage the hardware for you, and then as a service, you get to basically put your computing infrastructure in the cloud. Now, EC2 is really the most boring way to use AWS. You can take exactly what you have now, and you can put it in the cloud in an EC2 instance, and you're running in the cloud. What are far more interesting is everything else. How does this thing work? Okay, it's like a pointer thing, but it's like software pointer, I think. There we go. It's very fancy. Everything else. So that's actually where most of the interesting stuff sits. And I've got a picture here of just the AWS services, or rather a picture of the services that would fit on this page. There are a lot of them. So right there on the top left is where we can see EC2, and everything else is basically everything else that doesn't have that big arrow there. So now I think there's around 175 services now in AWS. There might be more. It changes all the time. But initially, back in the day when AWS just started out, there might have been this one service here, S3, or not just this one, maybe a few services, and it would have been amongst them. So what is S3? I'm sure people are quite familiar with the service. Like I said, it's been around for quite a long time. It stands for Simple Storage Service, and it's very similar to, you can think of it like a service in the cloud that allows you to share and host files. Except that you can't log into S3, you can't RDP into it or SSH into it. There's no underlying operating system as far as we're concerned, right? It's just an application. AWS has taken on all that other responsibility. So the comparison I've made here is that S3 is a bit like a file share, except in S3 your file shares are called buckets. And the files that sit in those buckets are called objects. And like file shares in Windows, you have permissions. So this is a screenshot of some permissions in Windows where you might have full control, modify, read, write, just a handful. When we start talking about permissions in AWS, there tend to be a lot more of them. So these are just the permissions, or rather actions. So in AWS, when we talk about permissions, we're talking about actions. These are about 70-odd actions that apply just to buckets in S3, right? So of that list of all those services, this is just the actions for buckets. So we can be very granular. We don't necessarily have to, but we have that ability in AWS. And I think that's the thing that jumps out first, or at least that it did for me when I started looking at AWS. So just to give you guys an example, if we wanted to allow a group of users to download something from our bucket, so a file, which is really just an object, we need to identify what action we needed. So it turns out that it's this action, get object. And if we wanted to now narrow this down to only allow our users to download objects from a specific bucket, then we'd go and find out what that bucket's identifier was. So in AWS, every resource or users, everything in AWS is called a resource, and they are identified with this long string called an ARN. You don't need to pay too much attention to that. You just need to know that they can be uniquely identified. And if we combine those two things, actions and resources together, we have what is called a policy. And a policy really defines how in your environment users or anyone else can access or what they can access. It identifies who can access what. So your first challenge in AWS is really to work out what actions you need are to get the thing you're trying to get to work. So these policies here, actions and resources, can't just exist in the ether. They need to be attached to something to be of any consequence. And that something can either be a user, which I think we're all quite familiar with, a group we're all quite familiar with, or this other thing, a role, which for me was quite new, but it's very similar to a user, except it's really just used for services typically. Although users can also assume roles. So all of these things are sort of a little bit interlinked. But what they all have in common is that we can attach policies to them. Now there's different ways we can configure these policies in our environment. We can either be very permissive, in which case we can say, okay, we're not going to worry about access control. You're allowed to do absolutely anything to everything, right? That is absolutely the easiest way to do something. It will definitely work. Access control is not going to get in your way. We can be a little bit more granular, so we can specify actions such as, I've got the S3 star, so that might be something like, sorry? I think I just heard an echo and thought I asked myself a question. We can be very specific with a specific service. So we could say, okay, our users are allowed to or they're allowed to do everything, but only in S3. So they don't have control of anything else, like maybe EC2. We could be more specific still. For example, like that previous slide I had with getObject, we can say, okay, our users can only perform this one action, right? Or 5 actions. Or we can be very, very specific, and we can say, okay, our users are only allowed to perform this one action on this one resource, or these 5 on these 5. So, I'm going the wrong way. Is it up? I'm going to switch to the old-fashioned way because I don't know how to use this clicker. Sorry. So when we all start out, we sort of start right from the beginning, right? We don't really have control over that. In our environment, we have administrative credentials in an environment that really just has nothing in it. That's how AWS comes when we sign up. The first thing you'll probably want to do when you sign up for AWS, and it's new to you, is get a feel for how it actually works. So what I did is I tried to get some practical experience by maybe spinning up some EC2 instances and deleting them. But after a while, everyone's going to think you're an expert, right? Like after you spent a few minutes doing something, that's sort of the idea. So imagine you were a sys administrator in a similar situation at an organization who's just using AWS for the first time, and you have this coworker, Bob. And Bob's heard that you've been playing with AWS. He's never heard of it himself, so he wants to come ask you for help to come and create him an account. So Bob comes in, asks you to create him an account for S3. This is something you've never ever done before. When you signed up for AWS, you got an account and it just worked. So you log into, you do some Googling and you work out, okay, it's actually quite simple to create Bob an account. What you need to do is you go to Identity and Access Management, which happens to be a service of those many, many services that allows you to add users. So you add Bob an account, you create him some credentials, you email them off to him, and you think you're done. But Bob's going to come back because you've really given Bob no permissions to do anything. So now you go and you Google a little bit more, and it turns out that you have to now attach this whole policy thing to Bob. So how do you do that? What you can do is you can look at the built-in policies that AWS provides. And these are sort of like these general case policies that AWS has prepared for people to meet a variety of cases. And this is really what most people do when they start using AWS, is they go and they look for the policy that sort of meets their needs. So in our case, we want to give Bob some form of S3 access. There's really nothing in our environment. S3 full access probably sounds right. We don't want Bob coming back again. But after a while of Bob using S3, he's going to be a wizard, and then he's going to start preaching to everyone else about how great this thing is. So at some point, you're now going to have to onboard the whole of Bob's team. But now you're a little bit reluctant because at this point, you started moving some business assets into S3. So you don't necessarily want to give everyone Amazon S3 full access, because if any one of those users gets compromised now, you're going to lose everything in S3. So instead, you chat to Bob, and Bob says, okay, all they really need is the ability to read these buckets. So we look at the page again, and well, I think everyone can see that this is probably the policy we'd pick. So we do, and life goes on. But now there's probably another use case that will arise, and one of them might be that Bob has a new starter called Tina. And Tina needs the ability to delete objects from our bucket. We're not interested in Tina reading stuff. She doesn't really need to do that in her role. But what she does need to do is tidy things up. But there's no built-in policy here for S3 write-only access. So now we have to take things a little bit further. So if we click on these policies here, and we actually look at what they look like under the hood, this is what that read-only access actually looks like. So over here, what is this thing? Aha, figured it out. So over here we have S3 get and S3 list star. So these are all actions that begin with that. So now we might see, okay, in S3, when we download files, it's called get, and when we upload files, it's called put. So we replace get with put, and off we go. We name this custom policy S3 write-only access. And this is sort of, I think, where most of our clients are. Writing these, maybe writing, on most occasions, using these sort of built-in policies, in some case, writing their own custom policies, but really around about here. Some clients go a little bit further, some maybe not, or even a lot further, but that's the basic idea. And I think the general theme is if we take those configurations we introduced earlier and we plot them from top to bottom, there's a theme we can see. They get more and more granular as you go down, and they get easier when they go up. And the general question is, where are we now and where should we be? In some cases, something like level 0, which is really just full access, it might make sense. If you're just starting out in AWS and you don't have any data in the environment, there's really no need to go through the additional overhead of doing granular policies. The worst case scenario there, if someone compromises that account, is that they might be able to spin up a couple of EC2 instances to mine Bitcoin. But there's not more than that. So if you're OK with it, then that's fine. The moment you start putting data in the account or some form of business data is when you start needing to pay attention to what policies you're using in the environment. If you only have one team, one user or two users using S3, you may not need to break that down further. If you've now got a team of S3 users, as we did in the previous example with Bob and his team, if one of those users gets phished, we don't want to lose everything. We'd probably want to split up these permissions. So then we're talking about something like level 2. If we're talking about big organizations who are using multiple services and have multiple teams with, responsible for multiple projects, where we really need to be is level 3. We don't want the team in the development team to be able to delete our production EC2 instances. Because that's the thing with cloud, is you can now delete computers, with a permission. So these things actually, they matter. And I think for the most part, our clients, or a lot of them at least, are sitting around here. And a question we started asking ourselves a while ago is, we know where they need to be, but what happens when they get there? What happens when they end up here? How do we approach security then? Because for us, it becomes really difficult as well. And that's what I want to talk to you about. When we start dealing with this level, we're talking about these really granular policies now. And we need to make sure that these things make sense and there's no risk arising from them. So I just wanted to give you an example here. If we have one user and that user is attached to 7 policies, we now need to review 7 policies in order to work out what actions this user can perform. If that user is a member of a few groups, those groups have policies. So we have to read those policies as well. If those policies grant that user the ability to assume a couple of roles, and those roles are attached to policies, we now need to read them as well. So just to work out what actions this one user can perform in an environment, we now have to look at 47, the combined effect of 47 policies, which is a very difficult thing to do. So we sort of took a step back, and we said, what is it we want to accomplish as a security consultancy with regard to AWS? And at a high level, what we want to do is we want to be able to spot these misconfigurations. And what does that mean to us? It means identifying the difference between who has access versus who should, who has access versus who should have. Have I read that wrong? No. I should probably know this, right? Who has access versus who should have access. But if we can't even determine what sort of access one person has, answering this question starts to become very difficult. Also, when we look at the cloud, something like working out what compromise means precisely also becomes very difficult. And I want to give you an example. So I know we've all just seen Jacques talk, and we've looked at tools like Pathfinder and Bloodhound. And when we start talking about being able to compromise a box with regard to Bloodhound, what we're talking about is having administrative access to that machine. That's how we move laterally within an environment. In AWS, if we take something like a bucket and you have admin to it, I'd agree we'd compromised it. But what if that bucket stored something like credit card information and we only had the ability to read it? I'd sort of classify that as being able to compromise it. The same goes for if that bucket hosted a public website and you could write to it. then write access starts becoming important. So when we're talking about all these actions, based on the context of what we're talking about, certain actions might mean certain things. So context becomes very, very important. So we sort of looked at what's out there, what can help us with security in AWS, and asked the questions that we usually ask when we do these sort of engagements. So when we're working on Windows networks, like Jacques said, and we use tools like Bloodhound, that's to sort of get a feel for how everything's fitting together so we can actually give some useful advice. But there's no real equivalent for AWS. There's no tech out there that can help us ask these questions. So what we ultimately decided to do was work at creating something ourselves. And that's really what I want to chat to you guys about. So I'm sure you can guess the way we think about things is in a graph, as Jacques just said. So what we wanted to do is take these big AWS environments, work out these relationships from processing these policies and understanding how everything fits together. And ultimately, we wanted to just put that in a graph database and see if we could get any useful intelligence out of that. So we went through this process, and this is what it looked like. So this is a huge mess, right? I don't think anyone's going to argue with me there. Most of these green lines are these actions, but I think it speaks for just how busy things are in AWS, right? There are a lot of actions, and everything affects everything. And which ones of these are dangerous? That's the next question. We don't necessarily know. So because we couldn't really make sense of this, we weren't sure, we needed to change things up a little bit. Our main problem here sort of starts to become, how do we extract useful information? So now this is just a free graph database sort of visualizer that we just dumped in everything, but we took the plunge and we thought, okay, we're gonna have to write our own user interface and use this data so that we can really structure things as the way we want. So what we did is we grouped actions by their type. So in S3, read actions would be get object and a couple of others, and we all put them together. And then the picture became a little bit clearer. So this is that same picture, and we've asked the same question. And something I maybe should have said earlier is the question we asked is, show us all of the access in the environment with regards to this important text file we've got in a bucket. Now that we've done this and we've grouped all these actions, so each of these colored lines over here represents a grouping of actions. And the red lines would be read, blue is write, yellow is list, and purple is permissions management. But you're not going to be quizzed, so you don't need to worry about any of that. But I think what we can really take away from this is that administrative access interconnects with everything, right? And that sort of makes sense. Admin, the definition of admin is it can do everything on anything. But it raises some interesting questions because no matter how we define compromise in an AWS environment, if you have this level of access, you're going to fit that criteria, right? We know this. So what we started asking is, okay, how do we get to admin in AWS? How do we spot attack paths, right? And that's when it sort of introduced this idea of effective access. We also want to know, is there any indirect way to get to object.txt? That's our target in this example. And to illustrate what I mean, I've got this example here. If we have a user called Kate, and Kate can read this bucket, but we have another user called Tom who can change Kate's password, then Tom can indirectly read this bucket. So what we did was we started looking through a list of actions in AWS, and we tried to spot ones that would basically produce a new edge for us, right? So the new edge here would be from Tom to Kate, which is sort of illustrated as change password. And we did this. There's a couple, if you do this yourselves, there's a couple that are really going to jump out at you. And the reason they do is because they have the potential to immediately give you administrative access. But the interesting thing is when you start looking at this and you start unpacking this problem is that you realize that a lot of these actions have dependencies. And to explain what I mean, I've got another example, right? So suppose we have a user who had just this policy attached. This is the entire picture. There's nothing more to it. And that policy let this user write arbitrary policies to a group, right? So this user could make any group admin, but they themselves are not a part of a group. So are they admin? The answer is no, they're not. Not technically, at least. They could make other people admin, maybe, but they couldn't be admin themselves. So it's a bit of a horrible situation to find yourselves in an attacker, and not a very realistic one, but I think it makes the point. If this user was a member of a group, and they have these same permissions, then they are admin, right? But what if they're not a member of the group, but they have the ability to add themselves to that group? What if the group doesn't exist, but they can create it? So now when we need to understand whether an attack is possible, we need to consider all of these different actions, which can be inherited in all of these different ways. So doing this in an automated fashion, just trying to work this out, became crazy. And it really sort of solidified in my mind just how difficult this would be to do manually. So, and to give you an example, right? We've spoken about this user being able to create, or this user being able to create groups and attach themselves to groups. We'll define those as attacks. So attacks can incorporate other attacks in order to produce a new attack. But every time you produce a new attack, the graph changes. If you can add a new policy to yourself, then you can perform the actions that that policy could do. So it starts getting really complex. So what we did was we defined these attacks in a dictionary at a high level, and we basically repeated the process of searching for these new attacks until the graph converged, or until no new edges were created. Yeah, so as I said, this really just sort of solidified how difficult this would be. Now, I've got a video prepared that I thought I'd show you, but I also have my laptop here with the actual software we've created, and I thought it might be quite cool for us to actually play with it ourselves. So this is the initial picture I showed you guys when I sort of introduced this object and who has access to it. If we update this view now, bearing in mind that we've now added effective access, I want to show you guys what that looks like. So we've created a lab environment in AWS, and we've basically pulled all that data down, and I've got it sitting on a local copy here, which I'm just going to show you. And I've got a mouse. Sorry, this is what happens when we do live demos. At least it's working. So yeah, guys, please feel free to interrupt at any point and ask about anything that's not clear. Like we don't have a huge amount of time, so whatever's interesting to you is the best way to go. So if you want to ask about something, just shout it out. You don't have to be formal. Please feel free to. But otherwise, I'm just going to keep talking. So if you want to keep quiet, I'm also happy to just go along. So these are those colored lines I was talking about earlier about grouping. So for us, if we click on this, and we can start seeing what these actual write actions are and what this means. So if we hover over here, we have some idea of what it means to, or what this action actually means, so we can put objects in our bucket. The one caveat here that I probably should have mentioned is that all of these nodes on this graph are resources in our environment, with the exception of this node over here with the crown. That's basically a pseudo state we had to create in order to sort of capture what it means to be admin. So that doesn't actually exist, but it's for us to get some context. So the first thing I really want to make to sort of compare this picture with the previous picture is all these new lines, all these new dotted red lines, right? Those are the new lines that have appeared because we've now taken effective access into account. All these colored lines on the top are the actions that can be performed by these policies. So what we're interested in here is working out who can effectively perform any actions on this object, which is quite important to us. So if we look at something like administrative access, which we would expect to, so this is a policy that's defined as so. So I hope that's clear to everyone, but basically what the definition for this policy is, it can perform all actions on all resources, right? And basically we've identified that it is effectively an admin policy. But what's interesting about this is that we've identified it based on what it can do and not what it's called, right? So it is identified to be an admin policy because it has the ability to edit itself and arbitrarily update itself to be anything. So this block of text here that I've shown you is actually a command. So there's two ways to access AWS. You can either do it through your web browser, which I think is the way most people do it, or you can access it from the command line using an access key. If we copied and pasted this command right now as using the administrative policy, we'd be able to transition from administrator access to effective admin, which isn't very interesting because it's the same thing. The policy wouldn't have really changed. We have this other example here of this user Alice, who also has an attack path to admin, which maybe might be a little bit more interesting. And basically, this is the example we looked at earlier, with the user who could add themselves to new groups and then arbitrarily update that group. And to sort of show you what I mean, if we just expand this node here, we can see what policies are attached to this user. So we can really start exploring environments now. We have the ability to answer these questions ourselves. And if we look here, here's the one policy that we spoke about, put group policy. That's what allows the user to arbitrarily update the group. But this user also has a policy directly applied to them. It's not even attached, it's embedded in the user. And that's where they've gotten these other permissions. And now the shortest path is to just use an existing group, which is Bob's group over here. So we can keep going through attacks if you guys like, but there's one I really want to speak about, and that's this one over here, IAM full access. So this is a policy that I hope everyone can see that. It's IAM : star. So what that effectively means is all actions that would basically match that. So everything that begins with IAM. And this is a built-in level 1 policy in AWS. That's effectively admin. And the reason is because a lot of the identity and access management permissions will give you administrative access. So what's happened here is this policy is attached to a role that's associated with an EC2 instance. Okay? So if we walk this path, what we're actually saying is that this EC2 instance is effectively an administrator in our environment. Whoopsie. Yeah, so I wrote this web interface, so it doesn't work very well. Wish I could blame someone else. So here I'm just searching for the thing I just lost because I zoomed out. So that was us just querying what's the effective access of this bucket. So to go back to this EC2 instance over here that has effective admin access, that's really interesting to us. And I was trying to think of a scenario to sort of put to you guys as to why we did this or why we created this configuration. And I really couldn't come up with one. But what I will say is that this is precisely the configuration we encountered the very first time we ran this tool at a client, just sort of trying to work out what's going on. And what we had there is about 7 EC2 instances that effectively had full control over the environment. So if any of those boxes got compromised, they'd lose control over their entire account, which is quite terrifying. Another thing that sort of arose is we wanted to try and work out beyond just permissions. We wanted to try and just piece together how everything fits together in AWS. So AWS is this massive thing, and we're still trying to learn it ourselves. I think everyone's sort of on that journey. So what we did is we went through all these things, and we said, okay, what actually connects to what? Just asking that question and just trying to piece together how all this information is arranged. And when we do that, if we click on this instance, we can start seeing all these different nodes that are actually associated with it. If you'll note, there are actually these dotted lines over here. They're not hardened. That's just because we've sort of declared in our graph that it's sort of associated. But what ends up happening is without us even trying, we can see that by some form of association, this instance can communicate with a different instance, right? And that sort of gives us some insight into networking, which is very interesting because an interesting question that might have occurred to us is when we found out that this instance had admin, is it sitting on the internet, right? Because if an application gets compromised on this instance, attackers now have this new ability to compromise the entire AWS environment. Another thing I sort of want to talk about is that policy we wrote earlier, which we sort of labeled custom write-only access. So some of you may have noticed that there was a bit of a mistake there. So just to remind everyone about the policy I'm talking about, it was the one where we replaced get with put. So this policy here is called write-only access. So we'd expect to only see this blue line here, but we happen to see this red line and this purple line. And the problem with that is if we actually look at what these permissions are, it means you can update the access control list on the object itself. So you could actually make this object public and read it, right? So it's probably not what we intended to do. The reason we spotted this is because we have this name, custom S3 write-only access, and we can see the effects. And often as consultants, we can see the effects, but we don't necessarily understand the intent. I think that was a point Jacques made as well. Often, if we're writing these things, so in the example where we were system administrators, we understand our intent, but we don't know what the effect is, right? And the best sort of outcome when is to work together and to sort of understand, what the net effect is. What did you mean to do and what did you actually do? And this tool is the same as Bloodhound in the sense that it's not really geared towards defense. So we could work together with clients. I mean, we ultimately do. That's the main job. But what I mean by that is we actually want to know what would be more effective than just finding these misconfigurations after the fact would be to prevent them altogether. And so we knew about Pathfinder's idea and its dream and what it actually wanted to accomplish. And something that really sounded quite cool to us was, what if we sort of tailored this thing to be the same thing. What if we integrated all the hard work we've done here to answer these questions in AWS and applied it to Pathfinder, right? The ability to write things real time here and understand the context would have far-reaching consequences. So I just want to show you guys a little bit of that. We can actually resolve these policies because we've done everything in the background. We can see when we look at these actions and we want to understand what they actually mean, this is what we're talking about. All these actions arise from that single policy. Another interesting thing is, what do they affect? We now have all these buckets here, right? Because when looking at resources. So something like topsecret.txt might be very interesting, or this specific bucket. But we really have a view now or some context on how our environment works. So I think there's not too much I want to click around here anymore. I'm just going to switch off to the slides. We've only got really one slide left, and then we can sort of go into questions. So where have I put this thing? Okay. I don't think it's coming back, but it's okay. That's fine. Anyway, there wasn't too much left. I basically just wanted to say that when we sort of started this out, one of the main questions we wanted to answer was what can do what to what. And I think we've succeeded to quite a lot there in that degree. We can sort of see that view, but we can't see it for everything. There's a lot of services we haven't yet added support for. And I think when we start doing work with our clients, engaging in these AWS projects, we can start to see what's actually important. What are people using, what's effective, and we can start building in that intelligence that we acquire when actually doing these projects ourselves. The other thing we looked at is what effectively can do what to what. And that really just amounts to identifying what these attack paths are in the environment. We don't know what all of them are. We've looked at a few. We've sort of demonstrated that we can actually put that in a view and sort of add that together and see what the sort of net effect is. But I think there's a lot still to discover. But I think the really cool thing about this is that what we've actually done is we've started working towards Bloodhound, right? We've got Bloodhound for AWS. Bloodhound came out ages ago, and it's being used by attackers, and only really now is it being applied for defense with things like Pathfinder. Right now, we've got a step ahead of the attackers. We can apply this for defense right now before an offensive tool comes out for AWS, and I think that's really quite cool.